Hi there, Year 8s. This is exercise 9F to do with gradients. Arguably, this is probably the most conceptual part of the chapter, and I do want you to take your time to learn what these different parts mean and what they do. So here we go. Let's dive right into it. So in your notes, I've got this equation, y equals mx plus c. Okay? I want you to write here that this is the equation for all straight lines. We call that linear equation. Specifically, it's a general linear equation. So if anyone ever asks you later on, what is the general linear equation? It is y equals mx plus c. Now within this equation, there are two key components. There's m and there's c. Okay, the x and the y are just the values that you put in and what you get out, but m and c are what we call parameters, and they dictate what will happen to the straight lines. Now m, fill in this spot, this is called the gradient. Okay, and c is known as the y-intercept. And if you remember from our previous lesson on x and y-intercepts, you can actually prove yc is actually called the y-intercept. But for now, just memorize that the number plus c, or whatever that c is, that's going to be your y-intercept. And the gradient, well, what is the gradient? And that's probably the most conceptual part that actually follows on in mathematics all the way to the end of year 12. It's a very big component as well. So it's a very simple idea, but there's a lot of applications that you can use. So here, what is the gradient? It is how steep a line is. So fill that in. Now I'm going to use Desmos to illustrate my point here, okay? So as you're copying those notes down, I'm just going to open up Desmos. All right, here we go. You know how I said y equals mx plus c? What's nice is when you type that in your Desmos calculator, what you can actually do, it says it adds slider, and if you just click all, what it'll do is it adds the sliders for the possible numbers that m and c can be. Now remember, I told you that y equals mx plus c is the equation for all possible straight line equations. So any straight line that you can come up with will fall under y equals mx plus c. Now m currently is 1. Okay, so m is currently 1 and c is equal to 1. So what they're really saying is they're currently sketching what you see on the right hand side here is they're sketching y equals when m is 1, so it's 1x plus 1. So you can see there c is 1 and m is currently 1. So you can see that's why my purple line is overlapping the red line. See how when I turn it on, it's purple, turn it off, it's and then red. Okay, so the red line is y equals mx plus c, but since m is 1 and c is 1, it ends up being this purple line. Now watch what happens when I change m. Okay, so we said m is the gradient. But what does the gradient mean? Well, the gradient dictates how steep a line can get. So watch what happens here. I'm going to increase the number. Okay, so the larger the number, so if I increase m, let's say m was 2. Let's say make m 2. You see how m now is steeper, so it's going up much faster than the purple line. So if I zoom out, you can see that it looks much steeper, doesn't it? Okay, so it's steeper on both ends there. Now let's see what happens when I move the slider. So I'm going to slowly move the slider. Can you see as I move it, can you see how the line's getting steeper and steeper and steeper, and it's actually getting closer and closer to the y-axis. Okay, it's getting closer and closer to the y-axis. So if I change the scale, and I said it goes up to 100, right? Watch what happens when I move the scale. So I get closer, I go to 14, 18, 20, 25, 33. So if m is 60, I'll say 60. I'll just write 60. If m is 60, you can see there that the line is so close to the y-axis, but it's still not actually equal to the y-axis. Even if I increase it to 1000, which actually looks vertical, doesn't it? But if you actually look closer, let's zoom in, and zoom in. There's actually not it's very steep, but it's not actually touching the y-axis, is it? It's still a little gap there. So even if I change to 10,000, it looks like it touches, but if you zoom in again, you can see there's always a gap between it. So that's what M does. M makes it very, very steep. So if you compare it to the purple line, you know, it's almost like it's vertical, but it's not, all right? So what I want you to write here is the larger the number, the steeper it is. And the smaller the number, so let's go on the other end, okay? So let's say I make M really small now, okay? So I'm going to bring it all back to 1 again. So M is back to 1. Now, smaller than 1 is like 0.5. Can you see how 0.5 is now flatter? So when M is the gradient, the number, if I change M to be 0.5, so what I'm really sketching is I'm sketching y equals 0.5 of x, and I'm still keeping the y-intercept as 1, so plus 1. And you can see that with this line here, 0.5x, that is still really, it's flatter than the purple. But then if I change it to 0.4, 0.3, 0.2, 0.1, can you see how it's getting flatter and flatter and flatter? Okay, now that's what the M does. And we haven't talked about what happens when it becomes negative, but I'm just going to change the step here so we can get a bit more of a visual what's happening. So I'm going to change this from here. It's currently 0.05. And you can see that as I'm making it smaller and smaller and smaller, it gets flatter and flatter. It gets closer to the x-axis, doesn't it? Whereas, what does the C do? C, can you see that if I move C, it actually just shifts the graph up and down. So what is C? And remember, I said C was the y-intercept. Now look at what happens when I put 2. When I put 2, if I zoom in, can you see the y-intercept is actually at 0, 2. 0, 2. Right there. So if I change this to be 3, then the y-intercept now is at 0, 3. If I change the y-intercept to be 3.5, then the y-intercept now is at 3.5. Can you see that? So C, whatever that equation you come up with, so if I wrote y equals 2x and I say plus 7, I know the y-intercept, it's going to be at 0, 7. So let's test that. I'm going to type in 0, 7, and I want you to see that for the green line, so I'm going to just take all the other lines away so you don't get confused, but I want you to see here, if I zoom up, scroll up, the y-intercept is actually at 0, 7. So that plus C, that's what it does. So in your notes, just write here, just so that you remember, C will tell you where it crosses the y-axis, or where the y-intercept is, really. Okay, and essentially it almost feels like it moves the graph up and down. So I'm going to write here up, down, if that helps you remember. Okay, and then just to fill in this spot here, the smaller the number, what we can see again, so if I just brought everything back, I'm just going to delete this, delete this, delete this, and I'm just going to make the y-intercept 0, so it crosses the origin, and I'll bring this red line back again. Okay, so we'll go back. Here we go. This is what it looks like, okay, if M was 0.2, okay, and the y-intercept, can you see how the y-intercept, because I made C 0, it's crossing at 0, 0. Okay, now let's see what happens when I change it to 0.02. See how it's getting closer and closer to the x-axis there. If I change it to 0.03 or 0.003 or 0.0001, now if you notice, if I keep zooming in, it looks like it's horizontal, but if you actually zoom in very closely, it's actually, wow, I've got to zoom in a lot. It's actually not horizontal, not perfectly. So there's always a gap there. And so same idea, the smaller the number, the flatter the line is, okay? But there's a difference between a positive gradient and a negative gradient. So we saw just now that when it was a positive number, the larger it is, it gets very steep. True, so large positive. When I made it 0.0001, it's still a positive number, but it becomes very flat. Okay, so small positive. So it's flat, right? So I should do a nice straight line, actually. Let's see, does that function come up? Yeah, it does. Okay, it's really flat. But what you can tell is, how do you know it's a positive gradient? Well, from left to right, can you see it's always slightly inclined? Okay, from left to right, it is slightly inclined. That's a positive gradient. So when your number, the number m is positive, it will always slightly incline from left to right. Okay, so if you can see here, if I go back and I change m to be 10, even though it's steep, it's still from left to right, it's inclining up. Yeah, so if I made it 5, it's still inclining up. Whether I made it 3, it's still inclining from left to right, it's going up. But as soon as I put a negative in front of it, like a -3, what I want you to see is this. See how it flips? It just goes from left to right, it goes down. Okay, it goes down. But it still retains its steepness. So if you had -30, it gets steeper. If I had -300, it's even steeper. But it's just the difference is that it's going from left to right, it's declining. Okay, so I'm going to draw here. You can have a very negative from left to right. Sorry, I should do it in pink. Left to right, it goes down from left to right. So a negative gradient makes it go down from left to right. Obviously, this is a large negative. If you have a small negative number, so if it was -0.1, you'll see that it's actually now flatter. See how it's flatter? And if I made it 0.01, it's getting even closer to the x-axis. See that? But from left to right, it's declining. Can you see that? It's slowly going down. So if you have a very, very small negative number, then it's flat. But this is small negative. And a small negative just makes the line look flatter. But from left to right, it's declining. See how it's going down? Whereas this is kind of like going up. See that? See the difference between the two? One goes down, one goes up. So that's a positive gradient versus a negative gradient. And the gradient is again determined by m. So is m positive or is m negative? Hopefully that helps you remember. Then there's these two boxes here. Well, straight lines, you can draw it like this. You can draw it like this. But there's also another two. You can also draw it full-on flat horizontal. Okay? So how would you draw it flat, full horizontal? Well, this is the hint. I'm going to show you. It is called a zero gradient. So you got a positive, negative. Well, when you have m equals to 0, so if the gradient is equal to 0, so watch this. If I change m to 0, you will now get a perfect horizontal line. No matter how much I zoom in, there's never a gap between the x-axis. See that? It's perfect. So when m is 0, it will have this flat horizontal line. So that means if I change this to, I'm going to make a new graph. Let's do another graph here. If I did y equals 0x, so m is 0, plus 3, can you see? 3 is the y-intercept, so the y-intercept is now at 0, 3, and if I label it, you can see it. That's where the y-intercept is, but it's a flat horizontal line. It's parallel. The red and the black lines are parallel right now. That is what m does. So when m is 0, you will have a flat horizontal line. So horizontal. Okay, when m is 0, you have a horizontal line, and that means that you can have a horizontal line anywhere you want. Let's say I want a horizontal line that crosses through 6. Well, all I have to do is I just have to say 0x, which means flat line, and the y-intercept at 6. And there we go. There's my line at 6. 0, 6 is where it crosses, and I get a horizontal line at 6. If you want it at -2, then -2. There it is. There's my horizontal line at -2. And it's parallel to the red line as well. Okay? So, your last one as part of your notes, this is a vertical line now. So you have a horizontal line. Well, you can get a vertical line. You can draw a vertical line. Now this one is slightly different. How do you get a vertical line? Very easy. In this case, there is nothing to do with the gradient. It's actually just whatever x equals to. Now, what am I saying there? Let's have a look. If I want a vertical line just running across through 2, I would say x equals 2. That's it. You see that? X equals 2. I get a vertical line at 2. And the reason why this works is because you're coming up with a rule. You're saying for all the coordinates, because remember, to draw a straight line, you need 2 points, right? Now, if I want a straight line at 2, I can have 2, 0. So here's a point, right? That's on the line. But to choose another point, it doesn't matter where. If you want a point on the line where it's vertical at 2, let's say at this point here, that has to be, x needs to be 2, and then y can be whatever you want. So you can see here, y is 2 and x is 2. But if I wanted, let's say, just above, I have to say x is 2 and then y could be 3. And it's still on the line. Can you see that? It's still on the line. So it's still vertical. So 2, 0, 2, 2, 2, 3. What's the pattern? Hopefully you're seeing there's a pattern here. There's a pattern that no matter what the y value is, as long as x is 2, I can say 33 if I want to, right? So y can be 33 and it's still on the line. See that? So the logic here is that as long as x equals 2, then who cares what the y is? As long as x equals 2, you will get all the possible coordinates that will draw this line. And that's why, in this case, when you want a vertical line, it literally is where x equals to any number. Whatever number you want. Whereas in this one, if you didn't realize, when m equals 0, so y equals mx plus c, that's your straight line, right? But if m equals 0, 0 times x is going to cancel out to be 0, and you just end up with y equals to c. And so that's why if you want a horizontal line, as long as you write y equals to any number, you're going to get a horizontal line. Now, you might be a bit confused there, so I'm going to show you. Watch what happens. I'm going to delete all of these because it can get confusing right now. I'll delete all of these, and I want you to see this. Watch what happens when I literally just type y equals 5. See that? I get a horizontal line at y equals 5. I mean, I could have wrote 0x for a gradient of 0 and then plus 5 to get a y-intercept at 5, okay? But I didn't need to type 0x because we already know 0 times x is going to be 0. So you might as well just write 5. See what I mean? Doesn't change the equation. So if I wanted a horizontal line at 10, I just type 10, y equals 10. There you go. That's my horizontal line. If I want a horizontal line at -5, I just type -5, y equals -5, and that gives me this. And the logic to this is the same thing again. If you were to pick coordinates to make it a horizontal line, right, I would have picked this. I would have said x needs to be 0, and then y can be -5, or y needs to be -5. You see that? Right there? That's on the line. Now, if I want it on the line again, I can pick any point on this line. So let's pick another one. As long as y is -5, doesn't matter what x is. X can be 2. And then as long as y is -5, it will sit on the line. See that? Same pattern as before. The pattern is that doesn't matter what x is. X can be -3. As long as y is -5, you will get a coordinate on the line. So the pattern is -3, -5, 0, -5, and 2, -5. What do they all have in common? Well, y is equal to -5. And that's what you're saying. You're just saying the rule is I don't care what x is. I just want the y coordinates to always be -5. And that's why you end up getting all the possible coordinates on this line, and hence you get a horizontal line. That's why it happens. Okay? So that's the theory for today. That's pretty much what you need to, and it's a lot of information. If you really unpack it, it's huge, right? So today's lesson, this is all you're doing. You're finding the gradient of the following graphs, okay? Now the gradient, we already know the steepness, but we don't know what the gradient is, okay? So I want you to fill in here, How do you find the gradient? This is the technique. So go back to your notes here, and I want you to write just above, gradient is equal to rise over run. And basically, how does a line get really steep? The line gets steep because you go up or down a lot. So up or down a lot, there's a much larger number going up or down versus how much you go across. So for example, if I only took one step across and then I went up 5 steps, can you see how the line is really steep? The gradient's very steep, okay? Whereas if I did it the other way around, if I walked 5 steps across and I only went up 1 step, can you see how the line is flatter? It's not as, the gradient is really flat. So that line versus say 1 across and 5 up, well, clearly this line, this second line is much steeper. So how do you determine the steepness of a line? Well, the larger your vertical numbers, the bigger your gradient is, right? So really, the gradient is found by looking at what the vertical distance is in comparison to the horizontal distance. Okay, and we always write vertical over horizontal. Or another way to remember it is y over x. Okay, now let's have a look at your example here. How would you find the gradient here? Well, to find a gradient, you need 2 points. You need to see 2 points. So I can see 1 point here at 1, 3. Where's another point? Right here, 0, 0. I can see it crosses exactly there at 0, 0. You got 2 points. If you were to look at from this point to get to this point, how far horizontal do I have to go? Well, I had to go across 1. And then I had to go 1, 2, 3, up. So if I went across by 1 and I went up by 3, okay, so that makes these 2 points here. If I connect those 2 points, that's how I got my straight line, right? So that's the line. That's how I made that gradient. Well, gradient m is equal to rise. So how much did I rise? I went up by 3 units. That's the vertical distance. Divided by, well, how far did I go across? I went across 1. So all in all, that's 3 over 1. 3 divided by 1 is a ratio of 3. So m equals to 3. Okay, so that's how you figure out the gradient. Let's do another one. I'm going to do it over here. You've got to pick 2 points. You've got to find 2 points so that you can know how much you go up and down by. I can see here there's a point at, again, the origin, which is 0, 0. So follow the same thing. If I need to go from this point to get to this point, how far horizontal do I have to go? Well, you can see you're going 1, 2 across, so 2 across. Okay, so 2 horizontally. And then I need to go up 1 to get up to this particular point. So I need to go up 1. So now that I've got my 2 points, when I draw the line, well, this gradient, what is the gradient equal to? The gradient is equal to your vertical distance, which clearly is 1. And then what's your horizontal distance? How far did you have to run across? Well, you ran across 2. So the gradient in this case is actually half. You can leave it as a fraction. You don't have to write it as 0.5. You can write it as half. And that's why you can see that the line in both cases, this one is steeper than this one because m is 3. In this case, m is half. Remember, we wrote before that the larger the gradient, the steeper the line, and the smaller the gradient, the flatter the line is. Yeah? So that's what today's exercise is. There's a lot of through the start here, and then there's much more practice for you to do here. I'm going to answer these questions here for you just so that you know how to do them. But maybe put it on a pause and practice just answering these questions, see if you're right or not. Okay, so I'm going to say the gradient for this one, just looking at it, I'm going to pick 2 points, and I can see here there's a 0, 0 coordinate. So it goes down 1, goes across 1. Notice I put a negative because I'm going down. So it's down, -1, so down 1. So vertical distance is down 1. And then I had to go across 1. So when I go across 1, it's a positive 1. So -1 divided by 1 is -1. That's my gradient there. Okay, so every time you go across, it's always positive because you're moving to the right. Yeah, because we always move from left to right. Same thing with this one. Let's pick 2 points. They've got 2 points here. Okay, so see, I'm going down. How much down am I going? I'm going 1, 2, 3 down, so -3 down. And then I'm going across 2. 1, 2. So I'm going across 2. So that means my gradient, what's my vertical distance? Vertical distance is down 3 across by 2, and it's a positive 2. So my gradient is, well, negative and positive is the same thing as writing a negative 3 on 2. You don't have to write it as a decimal. You can leave it as a fraction. So it's negative 3 over 2. That's my gradient. Let's have a look at this one. Now notice that this is a horizontal line. So it's crossing through y equals 2. So this point here is 0, 2. So the y coordinate is 2. And remember, with horizontal lines, gradient is 0. And we know that you can just say y equals 2. As long as y equals 2, you will always get a horizontal line. Does that make sense? You just remember what we were saying. If you want a vertical line, the coordinates, all of them, as long as the x coordinate is, in this case, negative 6, it actually doesn't matter what the y coordinate is. You will always get a vertical line. So test it on Desmos if you want, but here would be x equals negative 6, and here would be y equals 2. But if you were to say, what is the gradient? Well, the gradient here is 0 for it to be flat. So check your notes again. 0 gradient makes it flat. And here, this is what we call an undefined gradient. Okay, meaning it doesn't exist. You don't have a gradient because it's fully up. There's an actual theory as to why this works, but I'll talk about it later on when in another video or so. But right now, that's all I want you to practice to start off with. For these questions here, it might help if you plot the coordinates first so that you can see the distance. So 0, 2, and 1, 6. If you were to do this question here, 0, 2, and 1, 6. 0, 2 is over here. This is where 0, 2 is. And 1, 6 is 1 is here and 6 is up here. And over time, you'll be able to do this quicker because you realize that this is y is 2 because that's the y coordinate. And the y coordinate here is 6, right? So all you have to do is just figure out, well, 2 to 6, that tells you the vertical distance. So 2 to 6, so you just always look at the y coordinates. That should tell you the vertical distance. So vertical distance clearly from 2 to 6, 6 take away 2 is 4. So I know the vertical distance is 4. If you want to know the horizontal distance, just look at this one. Those are the x coordinates. You started off at 0. Okay, so 0 is over here. And then you're going across to 1, which is over here. That's a distance of 1. So 1 across and 4 up. 4 up. And so you know that the gradient of that line must then be, for this one anyway, I'm just going to go back here. So gradient has to then be rise by 4, run across by 1, so gradient is 4. Okay, so over time, you don't actually have to plot the coordinates to see it, but you can actually just visualize it or just think about it. These are the y coordinates. So if I drew it out, you're starting off at 6. So here's 6. And you're going all the way down to 0. So here's 0. 0 is here. So vertically, my vertical distance is 6 units. If you look at the horizontal coordinates, you're from negative 5, which is over here, you're going all the way to 1. So horizontal distance is clearly negative 5 to 1 is 6 units as well. The only thing that you don't know is, well, what kind of gradient is it? Is it negative? Is it positive? Is it 0? Is it undefined? So it helps to sort of plot the coordinates to visualize it. But over time, you can do this in your head. 1, 0 is over here. That's where 1, 0 is. And then negative 5, 6. Negative 5, 6 is here. X is negative 5 and the y coordinate is 6. So you can see that the gradient clearly is negative. And it just means that we just worked out that the vertical distance, before we just said it was 6, because from 6 to 0, that's a distance of 6. And then you knew from negative 5 to 1, we knew it was 6 units. So let's put it together. Gradient is equal to rise, which is 6. Oh, sorry, actually went down by 6. Went down by 6. From left to right, it goes down. So down by 6 and then across by 6. So negative 6 divided by 6 is negative 1. Now, I know this is a hard exercise. I know some of you might have tuned out at this point. That's why I'm saying just go back to what I was saying before and just start off with these types of questions. Okay, once you get better at just the graphing coordinates and reading the gradient, then you can try doing the ones with the coordinates like that one. Okay, so the ones with the coordinates are much harder because you don't have a visual stimulus, but I reckon you should start off with just the graphs. But hopefully now you understand there are 4 types of gradients here. I forgot to fill this in. This is undefined gradient, and these are the notes. So it's very simple notes, but it gets really complex. I get it. Okay, if you made it all through this video, fantastic. It's a lot of notes to take in and a lot of information to digest.